Today's lesson is continuation of section 9.2, multiplying polynomials. In the first part of this section, we talked about multiplying polynomials together. And we talked about there's a couple ways you can do it. One way being by using our distributive property, something that we've used in the past, to multiply numbers and variables together. And then we talked about what happens now, getting a little more into advanced, like the intermediate algebra here. A problem like this, what if I'm multiplying two binomials together? Again, binomials because they each have two terms in them, 2x plus 3, and then another binomial 4x plus 1. What if I'm multiplying two binomials together? We talked about one method you can use for this, and that was using the table method. So what I would do is, and again, it doesn't matter how I arrange them, 2x plus 3 I'm going to put as a row or a column in this table on the outside, and same thing with 4x plus 1. And again, just to show it doesn't matter, I'll take the second one here in this case, and I'll put that up top this time, 4x plus 1. I think I did it the other way in all my other examples. And then on the left side here, I'll put 2x plus 3. Again, how did the table method help? It's just a nice way to make sure that we multiply all the terms together that we need to get our answer. So now, I look at each one of the squares here in this table, and the top left one, this one is going to be the result of when I multiply 2x and 4x together. It's the result of that row and that column of those two terms. So 2x times 4x, well, that'd be 8x and then squared, or x times x gives me x squared. That's the number times itself. That's how I represent that. Okay. In the top right here, now I'm going to multiply this top number and then the one in this far row here, so 2x times 1. And that's going to be my result. I'll put in this top right square. So 2x times 1 gives me 2x. The bottom left square, I'm going to multiply 4x times 3, which gives me 12x. And the bottom right square will be 3 times 1, the last two things to multiply together, which just gives me 3. Once I've then ensured that the table method has ensured that I multiply all the terms together that I need to, now I just collect like terms like you would when I'm adding or subtracting, and have my simplified answer, my simplified product. I'm going to write the one with the highest degree here first, which is 8x squared. So that's going to lead off in my polynomial here. Then I've got 12x and 2x. They're both positive, so I'm going to add those together. 12x plus 2x gives me 14x, combining those like terms. And then I've got my plus 3 here at the end. So that's just kind of a review of the first method we talked about, table method, which I think is a very nice way to make sure that, and it's a nice visual way to make sure that you multiply all the things together that you need to. Now the book has two other methods that I'm not going to really go over in my lesson, but if there are ones you'd like to try out or ones you think might work well for you, then I would encourage you to try them. And here's the pages that has those two methods on. It's multiplying polynomials vertically, as it says here, multiplying them vertically or multiplying them horizontally. Again, I feel like if we know two methods, and you can pick one of those two, I think that's good enough. And I'm going to pick out the best two to show us. These two, again, are fine methods as well. They will work. But I just don't think we need to know 5 different methods to multiply polynomials together. I'm going to show you the two that I think are the most helpful. And then you can pick the one you want to use the most. So, but just kind of showing these again, there's a vertical way to multiply polynomials. It kind of goes along with, I've written this example up here. It's kind of like when you multiply numbers together, like 932 times 41. So I take, if this was a term, I'd take this term times 2, then times 3, and then times 9, and then move on to the next one. So, and you kind of see a little example of what they have right here. That's exactly what this example shows. And then the horizontal method is actually kind of similar, except just leaving the problem horizontal as to making this the multiplication algorithm here. It is the same kind of idea, though, just taking one term and make sure you multiply it by that binomial. Taking each term in that trinomial and multiplying it by each term and kind of distributing it to each term in the binomial. So, and you can look at this, again, these two methods, and they are on page 563. So if you want to look at those and try those out, that's fine with me as well. But you don't have to write any, I'm not going to require any notes on those. Just know where they are, where that resource is if you'd like to use it. I'm going to now go through the other method, though, that I think is going to be helpful. So again, the two methods that I'm going to promote here, one I've showed you already here, an example, and I showed in the first part of this lesson. So table method. This is one way we can do problem where I'm multiplying some polynomials together, and then now going to a new page. The second method is called the FOIL method, and that's just an acronym to stand for the terms that you're going to multiply together when you're multiplying two binomials together. So it's called FOIL, the FOIL method. It does the same thing the table method does, just without the nice table visual. It still makes sure that I multiply each term in the first polynomial by each term in the second polynomial. And in this case, again, usually we're talking about binomials in these cases, because that's what we'll end up multiplying together a lot. But so FOIL, each letter stands for the terms you're going to multiply together. F stands for you multiply the first terms in the binomial together. O stands for multiplying the outer terms. I stands for the inner terms. And L stands for the last terms. And now I'll kind of show that here. The arrows on my diagram also show it as well. But I'll just kind of make up an example and show to what I'm talking about. So let's say this is my problem, and I'm going to multiply these two binomials together. The FOIL method, again, just a way of making sure you multiply everything you need to. So the first terms, what we're talking about is the first terms in each binomial, so I have to make sure I multiply those together. So 4x times 2x, and that would give me 8x squared. The outer terms, so it's saying the outside terms there in this case, and my problem, so the 4x and then the negative 7. So I got to make sure I multiply those together. That would give me negative 28x. The inner terms are the ones closest together here. This negative 3 and this 2x, so that's minus 6x. And then the last terms in each binomial, so negative 3 and negative 7, which would give me positive 21. And then I could collect like terms in my problem to get my result. 8x squared minus 34x plus 21. Again, is this any different than what I would get with the table method? No, I would get the exact same answer. I can even kind of show that up here briefly too. Just say I wanted to multiply these two binomials together with the table method. So I'd have 4x and the minus 3 on the top, let's say, 2x and minus 7 along the side. In each box, I would put what I get when I multiply that row and that column together. So here I would get 8x squared. In the top right, I get negative 6x. In the bottom left, I get negative 28x. In the very bottom right, I get positive 21. What do you know? That's all the same terms that I got right here. And then when I combine like terms, I would get this same answer. So again, just realize this FOIL method, again, it is just that. It is just another method to get to the correct answer. I'll just go through an example here too then, just to make sure we have the idea. But also I'd like to reemphasize this, and you did write this down if you saw the first part of this lesson in 9.2. You did write this down already, but I'm just going to reemphasize it. Because again, both these methods, the table method and the FOIL method, work great. And again, I think they're my favorite two out of the bunch that they show you in this book. I like the visual of the table method. But I also, when I was doing math, I grew up with the FOIL method. I think that one's nice and quick as well. So either one will get you the right answer. But the main thing you just have to do, the main thing you have to make sure though, whenever you're multiplying polynomials together, as long as you take care of this, you'll be fine. As long as you make sure you multiply each term of the first polynomial by each term of the second, then you're going to get the answer. So whether you use the horizontal or the vertical, like those ones on the page I showed you, or whether you're using the two that I'm showing in class, it doesn't matter. Any of those methods are just ways to make sure you multiply all the terms in the first one by all the terms in the second one. You could even think of the FOIL method. I've had students tell me this as well, and I'll do it for this first problem here. I've had students telling me, well, the FOIL method is really just like distributing. It's just that you just start with the first term and then go to the next term, and you just make sure you distribute each term to the second binomial. So yeah, you could actually see it like that. Think of it like distributing. Let's say we're distributing this 3x, and I would multiply it times x, and I would multiply it times negative 4. Well, isn't that exactly what FOIL's doing too? FOIL says multiply the first terms, which would be, yeah, 3x and x. And then multiply the outer terms. Remember, it spells FOIL, so multiply the first terms, 3x and x. The outer terms would be, yep, 3x and minus 4. So that's what I've done so far. And then, after I've multiplied 3x times each of the ones in the other binomial, then I would take negative 1 and say, oh, negative 1 times x and negative 1 times 4, like distributing that. And again, that's just like saying, oh, the inner terms, negative 1 times x. And then negative 1 times negative 4 is like doing the last terms. So yeah, some students recognize it as like that. As it's just like distributing. I just have to make sure I distribute both the terms. If you want to see it like that as well, that's another good way you could interpret the FOIL method. Any of those interpretations works. If it helps you to think, okay, I have to multiply the first terms, 3x squared, and then the outer terms, so negative 12x, the inner terms, negative 1x, and then the last terms, plus 4, that works for me as well. And again, that's what FOIL method is having you doing. Just making sure you multiply the terms together that you need to. Reducing this one, 3x squared, and then negative 12x and minus 1x is going to be negative 13x, and then plus 4. So here's what I get for my result. If I even use table method, it would still give me the same exact result. So again, what I'm going to show students in class is I'll show them the table method, and I'll show them the FOIL method. And whatever one you like better. I might have you try one here, try a little bit of both here in the beginning, but as we go on, whatever one you like, you just pick the one you're comfortable with, and that'll be fine with me. So we're just going through one more example here or two just to make sure we got the idea. Same thing on number 3 here. Let's say FOIL method. So F-O-L, F-O-I-L. Got to be able to spell it right. But yeah, F-O-I-L. So I'm going to multiply the first terms together. And I actually do like kind of, you can underline them or draw the arrows. I actually do kind of prefer drawing the arrows. So 2y times 4x. What's that going to give me? That's going to give me 8xy. So I just have both those variables after my number then. 8xy. There were the first terms. Here's the outside terms. 2y times negative 13 would give me negative 26y. Negative 26y. Then I'll go to my second term here. And now my inner terms would be negative 12x. And then my last terms, negative 3 times negative 13, give me positive 39. In this particular problem now, notice that I have 8xy minus 26y minus 12x plus 39. I don't have anything there I can combine. Those are all different terms. So nothing there that I can combine. That's just my final result right there with my product. Last thing I would mention is I showed you how to, in the first part of this section, how we can still use the table method even if we have different polynomials multiplied together. Like, what if I have a binomial times a trinomial? Well, there is still a way you can multiply those together. What about and we showed that with the table method in that first lesson, if you want to go back and check it out as well. What if we're using the FOIL method and we have a binomial times a trinomial? Well, again, as I've kind of shown you already though, the FOIL method is just when you have two binomials, it's a way to make sure you multiply everything together that you need. Okay. Again, it just all comes back to this statement though. Okay? As long as you multiply each term in the first one by each term in the second one, it'll work. So even with this, in this problem I've got here, if it's a binomial times a trinomial, I can still think kind of like the FOIL method, but it's almost like we talked about. It's like distributing. So I would just kind of think of it that way. Well, 2x times 5x squared, and then 2x times 4x. And then 2x times 8. And I write each of those answers there. So just kind of going through this one quickly. 10x to the third I would get for the first one, for the first set there. And then minus 8x squared. And then plus 16x. And then I would just take the second term and multiply that by each individual one. So negative 3 times this one, and times this one. And I'll see what I get here. I'd get, well, if I keep multiplying, I'd have negative 3 times 5x squared, give me negative 15x squared. And then plus 12x, the two negatives will cancel and give me plus, so plus 12x. And then minus 24. So again, still very much like FOIL method. But I just got to make sure I multiply both terms in the binomial times each term in the trinomial, as I've kind of showed there. So I'll collect like terms here to finish this one up. 10x to the third would be my first degree, my highest degree for the problem, so I'll put that one first. I can combine this negative 8x squared and this negative 15x squared to negative 23x squared. And then 16 and 12x, so that'd be plus 28x. And then minus 24 at the end. So here's what I get for my result. Again, showing how even with FOIL method I can still multiply two polynomials together. It doesn't matter how many are in each one. Again, it all comes back to this making sure I multiply all the ones in the first one by all the ones in the second one.